All right, so today we're diving into how to learn data structures and algorithms for interviews.
Okay.
You're probably listening to this deep dive because you are in the coding world, and you might even be prepping for, those tough tech interviews, maybe even at one of the FAing companies.
Right.
But we're going beyond just like the surface level here.
Yeah.
Our mission is to really like dissect this guide,
Yeah.
pull out those golden nuggets, and really equip you with the knowledge to not just survive those interviews, but to stand out.
Exactly.
Yeah.
And you know what's so fascinating is that while this guide is geared towards interviews,
Yeah.
the core concepts of data structures and algorithms,
Right.
DSA for short, have implications way beyond just landing a job.
Right.
It's really about, crafting elegant code that's not just correct, but also efficient.
Yeah, and I was reading this article about how a poorly implemented search algorithm
Oh, wow.
literally brought down a major e-commerce site during like a huge sale, and they lost millions. And that's when it really hit me like, wow, efficient code really matters in the real world.
Yeah.
So let's talk about how this guide helps us avoid those disasters.
Oh,
It all starts with the fundamentals, right?
absolutely. The guide really emphasizes picking the right programming language first.
Yeah,
It's kind of like choosing the right tool for the job,
right.
right? They suggest Python if you're
Yeah.
a bit newer to the game just because of its readability.
Yeah, Python's a good starting point for sure.
And then there's Java, which is a workhorse in enterprise development.
Yep.
And for those situations where speed is absolutely paramount, C++ is still the champion.
Makes sense. I remember when I was first learning about sorting algorithms back in college, and I was like,
Yeah,
who really cares if it takes a few milliseconds longer?
right.
But then, you start dealing with data sets the size of all of Twitter's tweets, and suddenly those milliseconds matter.
They really do.
So that's where big O notation comes in, right?
Yeah, that's exactly where the guide brings it in. It's all about understanding how your code's performance scales as the data grows.
So it's kind of like looking beyond those initial milliseconds and seeing how your code would handle a tidal wave of data.
Exactly.
Mm-hmm.
And if we, connect this back to the bigger picture,
Mm-hmm.
it's understanding that the most elegant solution isn't always the most efficient.
Interesting. Okay, so we've got our language sorted. We're thinking about efficiency. Now let's talk about data structures.
Okay.
The building blocks of any good algorithm,
Right.
and the guide compares them to a builder's toolkit,
Yeah.
each with its own specific purpose.
Exactly.
So we've got the basics like arrays and strings.
Right.
Those are like your trusty hammer and nails, always reliable.
Always there for you.
And then there are linked lists, which provide more flexibility in how you manage memory.
Yeah, they're kind of like a chain where you can easily add or remove links.
Yeah, that's a good analogy.
Right.
And then there's stacks and queues, which sound so deceptively simple.
They do, but they're everywhere.
They underpin so much of what we do in programming.
It's fascinating to think about how stacks are used in managing function calls, making sure everything happens in the right order.
Yeah, it's all about order.
And then queues. Well, think about any time you have a task list or a priority system.
Right.
That's a queue in action.
It's true. And then things start to get really visually interesting when we move into the world of trees and graphs.
Yes.
It's like one of those intricate diagrams you see in a spy movie mapping out these complex relationships.
Exactly. And trees are particularly valuable when you're dealing with hierarchical structures.
Like what?
Well, take a file system, for instance. You've got your root directory,
Okay.
then folders within folders, files within folders. It's a perfect example of a tree structure.
Yeah, I see it.
Right.
And then graphs are like the ultimate relationship mapper, right?
They are social networks, recommendation engines, mapping software. They all rely on graph algorithms to make sense of connections and pathways.
It's mind-blowing how these things work behind the scenes. But how do we actually navigate these structures and find the information we need?
That's where algorithms come in, providing those step-by-step instructions for solving problems.
So if data structures are the ingredients, algorithms are the recipe that tell us how to combine them to create something delicious.
Or in our case, efficient and effective.
Exactly. And the guide really emphasizes that mastering algorithms isn't about memorizing a bunch of formulas.
No, not at all.
It's about understanding the core strategies behind them.
Exactly.
So we've laid a solid foundation. We've got our tools, our ingredients, our general approach.
Yeah.
But now we need to get specific.
Yeah.
What are some of the essential algorithms that this guide recommends we really sink our teeth into?
Okay, let's get into it.
I'm ready to get my hands dirty.
Right. I love that enthusiasm.
Yeah.
That's exactly what you need to tackle this next section. Our guide dives into specific algorithms that are practically interview staples. And you've already hinted at one of the big ones, Sorting algorithms.
Ah, yes. Sorting algorithms. It feels like a rite of passage for every programmer to learn, like bubble sort insertions, sort merge, sort. But why are they given so much weight in these interviews?
It's not just about, being able to sort a list of numbers, though. That's important. It's more about understanding the logic behind each algorithm, its strengths and weaknesses, and knowing when to use which one.
So it's about problem solving, not just like memorizing code.
Exactly.
Yeah.
For example, you might be asked to sort a massive data set where memory usage is a big concern.
Okay.
In that case, you'd need to think beyond simple bubble sort and consider something like merge sort, which is way more efficient for those huge data sets.
That makes sense. It's about understanding the trade-offs and being able to justify your choices.
Right.
Now, what about searching algorithms? At first glance, they seem pretty straightforward.
Yeah, they seem simple, but there's more to them than you might think.
Yeah.
The guide highlights the difference between linear search, which is like checking every single drawer in a filing cabinet until you find what you're looking for. And then there's binary search, which is way more efficient, but it requires the data to be sorted first.
So it's like if you have one of those labeled filing cabinets, you can quickly narrow down your search.
Exactly. It's incredibly fast, but it only works if the data is already organized. And that's a key takeaway when choosing the right algorithm. Sometimes you need to do some pre-processing to set yourself up for success.
It's like planning your route before you start driving. Sometimes the scenic route is fine, but if you're in a rush, you need to take the highway.
Exactly. Now let's venture back into the world of graphs. Our guide spends a good amount of time on graph algorithms, and for good reason. They're everywhere: social networks, mapping, software, even financial modeling.
Oh yeah, I remember when I first learned about Dijkstra's algorithm, it felt like magic. You could feed it a map with all these twists and turns and it would just spit out the shortest route.
Dijkstra's algorithm is a classic example of how powerful graph algorithms can be. And it's used in tons of applications where finding the optimal path is crucial. Like think about ride-sharing apps or package delivery networks. They rely on algorithms like Dijkstra's to make sure everything is efficient and keeps costs down.
It's amazing how these algorithms are working behind the scenes in so many parts of our lives. But some of these algorithms can get pretty complex. How do we even begin to understand them?
Yeah, some of them can be a bit intimidating. The guide emphasizes breaking those complex algorithms down into smaller, more manageable pieces. And visualizations are super helpful too.
Okay.
There are some amazing online resources that let you step through an algorithm line by line and see how it actually works.
So it's like taking apart a clock to see how all the gears and springs work together.
Exactly. And don't be afraid to experiment.
Yeah.
Write your own implementations of these algorithms. Play around with different inputs. See what happens when you change things up. That's how you really get a deep understanding.
It's about getting your hands dirty and not being afraid to make mistakes.
Absolutely. Now, there's one specific algorithm that our guide points out as super important for interviews: dynamic programming.
Okay, dynamic programming. I've heard the term, but I'm not sure I totally get it.
So think of it as a way to solve those really complex problems by breaking them down into smaller, overlapping subproblems. And then you store the solutions to those subproblems, so you don't have to keep recalculating them over and over again.
So it's like having a cheat sheet for the hardest parts of the problem.
Well, kind of. It's super efficient for problems where you see the same patterns repeating. The guide gives a great example of using dynamic programming to calculate the Fibonacci sequence.
Ah, the Fibonacci sequence brings back memories of high school math class. But how does dynamic programming make that easier to calculate?
Well, the way we usually calculate the Fibonacci sequence involves a lot of repeated calculations. But with dynamic programming, you store the results of those calculations and then just reuse them whenever you need them. It's like having a lookup table that saves you tons of time and effort.
So it's all about optimizing for efficiency. But let's be real. Even when you understand these algorithms really well, coding interviews can be nerve-wracking. What advice does the guide give us for handling that pressure and doing our best?
The guide stresses the importance of preparation, not just in terms of technical knowledge, but also interview strategy and mental game.
So it's about being a coding ninja A&D and interview Jedi.
Exactly. One of the biggest tips is to practice talking through your thought process as you code.
Okay.
Think of it like you're giving your interviewer a tour of your brain as you're solving the problem.
So it's not just about writing code that works, it's about showing how you think and how you communicate.
Exactly. And don't be afraid to ask questions if anything is unclear. It
Mhm.
shows that you're engaged and thinking critically. And it's a good way to buy yourself some time if you need to collect your thoughts.
That's a good point. Okay, so technically we're practicing our communication skills.
Yeah.
What about those times when we just get stuck? Because let's be honest, it happens to everyone.
Yeah, it definitely happens. The guide suggests having some strategies ready for when you hit that wall. First, don't panic. Take a deep breath and break the problem down into smaller parts. Sometimes just saying the problem out loud can help you see it in a new way.
It's like talking to a rubber duck. Sometimes just explaining the issue to something can help you figure it out.
Exactly. And if you're still stuck, it's okay to ask for hints or guidance. It's better to ask for help than to waste time going nowhere.
That's a good reminder. Sometimes we get so focused on trying to do it all ourselves that we forget to ask for help.
Right. And remember, interviewers aren't looking for perfection. They're looking for problem-solving skills,
Mhm.
adaptability, the ability to learn from your mistakes.
So it's about showing your growth mindset and that you're willing to take on those challenges.
Exactly. Now let's move on to some of the practical resources that our guide suggests for practicing DSA and getting ready for interviews.
Okay, the training grounds for coding ninjas. What are some of the best options?
Well, online platforms like LeetCode and HackerRank are practically essential. They have tons of coding challenges from basic to super hard, and they provide a structured way to test yourself and track your progress.
It's like a personalized coding dojo with endless sparring partners.
I like that analogy. And then there are interactive platforms like Algo Expert and Algo Academy. They take a more guided approach with video explanations, step-by-step walkthroughs, and even mock interviews to help you prepare.
So it's like having a personal coding sensei giving you feedback.
Exactly. And of course, you can't forget about the classic books like Cracking the Coding Interview.
Right.
They're full of insights from experienced interviewers and strategies for common interview questions.
Those books are like ancient scrolls passed down from coding masters.
The key is to find the resources that work best for you and how you like to learn. Some people like structure, while others prefer to figure things out on their own.
Yeah, different strokes for different folks.
And remember, it's not about cramming. It's about really understanding these concepts and developing those skills that'll help you throughout your career.
It's a marathon, not a sprint.
Now let's shift gears a bit and talk about what happens after you ace those interviews and land that dream job. The learning doesn't end there.
So we've conquered the coding interview, we've got the job. Now, how do we keep those DSA skills sharp and stay ahead of the curve?
That's such a good question, and it's one that our guide addresses directly. It emphasizes the importance of continuous learning and gives us some tips for staying engaged and expanding our knowledge.
So it's like graduating from coding boot camp and then starting a lifelong journey of coding mastery.
Exactly. One of the best ways to stay sharp is to make practice a regular part of your routine. Even if you're not actively prepping for interviews, set aside time each week to work on coding challenges or explore new algorithms.
It's like going to the coding gym, even if you're not training for a specific competition, you just want to stay in shape.
Exactly.
Yeah.
And online coding platforms are great for this. They always have new challenges to keep you engaged and learning. You can even compete with colleagues or friends for extra motivation.
It's like having a coding sparring partner to keep you accountable.
Another good way to stay sharp is to do coding contests or hackathons. They're a lot of fun, and you get to test your skills against other talented developers.
It's like a coding tournament. You see how you stack up against the competition and learn from other people's approaches?
And speaking of learning from others, don't underestimate the power of teaching and mentoring. When you explain concepts to others, it really solidifies your own understanding and helps you see where you might need to improve.
It's like the saying, the best way to learn is to teach.
Exactly. You could mentor junior developers, contribute to open source projects, or even write technical blog posts to share your knowledge.
Sharing what you know helps others. A&D helps you become a better coder.
Absolutely.
Yeah.
And don't forget to stay updated on what's happening in the field. Follow tech blogs, attend conferences, read research papers to learn about new algorithms, data structures, and problem-solving techniques.
It's like keeping your coding toolbox up to date with all the latest and greatest tools.
Exactly.
Yeah.
And finally, remember that learning DSA isn't just about abstract concepts and theory. It's about applying those skills to real-world problems and building cool things.
Taking those coding superpowers and using them to make a difference in the world.
Exactly. Look for chances to apply your DSA knowledge at work or in personal projects. You can analyze and optimize existing code bases or develop tools and applications that use advanced data structures and algorithms.
Turning those coding dreams into reality.
Absolutely. And the learning never stops. The more you explore, the more you discover, and the more exciting that coding journey becomes.
So keep that curiosity alive. Embrace those challenges and never stop learning. It's amazing how this guide manages to be both practical and inspiring, you know?
Oh.
We've gone from interview prep to thinking about lifelong learning. But there's one section I'm super curious about,
Yeah.
the one on advanced DSA concepts. It feels like a peek into those secret labs where the real coding wizards work.
I like that. That's a great way to put it.
Mm?
This section is definitely for those who want to go deeper, you know,
Yeah.
push the boundaries of their knowledge.
So what kind of crazy stuff are we talking about here?
Well, if you like specialized data structures, the guide gets into things like segment trees and Fenwick trees.
Okay.
They're super efficient for handling range queries and updates on arrays, which can be really useful in certain situations.
To be honest, those sound a bit intimidating.
Yeah.
Are we talking about like theoretical computer science stuff here?
Not necessarily. They might sound complex at first, but the main ideas are actually pretty intuitive. And you'd be surprised how often these more obscure data structures can actually lead to really elegant solutions for real problems.
Okay, so give me an example. Like, when would a segment tree be the best tool for the job?
Okay, imagine you're building a system to track stock prices over time,
Okay.
and you need to be able to quickly answer questions like, what was the highest price during this date range?
Got it.
A segment tree can handle that kind of query super efficiently, way faster than just brute forcing it.
So it's like a super-powered index for your data.
Exactly. You can find specific information without having to scan through everything.
That makes sense. What about algorithms? Are there any advanced ones that stand out?
Oh, yeah, for sure. The guide talks about network flow algorithms.
Oh,
Those are used to optimize flows in networks, like think traffic routing, supply chain management, even matching organ donors with recipients.
wow. Network flow algorithms sound like they can solve some seriously complex real-world problems.
They absolutely can. And then there's linear programming, which might not sound exciting, but it's actually a powerful optimization technique used in fields like economics operations, research, even machine learning.
I thought linear programming was just a business school thing. How does it connect to DSA and coding?
Well, it's all about finding the best solution within certain limits. Imagine you're running a factory and need to figure out the most efficient way to use resources to maximize production while staying on budget. Linear programming can help you model and solve that.
So it's like a super-powered spreadsheet.
Yeah, exactly.
Yeah.
It can analyze those complex situations and give you the best possible answer.
Cool. And of course, we can't talk about advanced topics without mentioning machine learning.
Right, machine learning is a huge and constantly growing field. But at its core, it's about using algorithms to help computers learn from data and make predictions or decisions.
So it's like teaching computers to think, but in a controlled way.
Exactly. And while mastering machine learning takes a lot of time and effort, understanding the basic algorithms and data structures behind it is a great starting point.
It sounds like this advanced section is like a portal to a whole new world of possibilities.
It really is. And remember, the most important thing is to stay curious, keep learning, and don't be afraid to take on those tough challenges.
Well, we've covered a ton of ground in this deep dive. From the basics of data structures and algorithms to advanced topics and even some career advice.
We have.
It's been like a crash course in coding.
It has been a really interesting conversation. I hope you're feeling ready to take on your own coding challenges.
Yeah, me too. And if you're listening and you want to level up your coding skills, definitely check out the full guide. We'll include a link in the show notes.
And remember, learning DSA is a journey, not a destination. Enjoy the challenges, celebrate your wins, and keep exploring the amazing world of code.
That's a wrap on this deep dive into the world of data structures and algorithms. Thanks for joining us, and happy coding!